we are going to add the flight seat sub-entity to our reality that will represent each seat of a flight. The way to identify each seat will be by providing the identifier of the flight it belongs to, the identifier of the row, and a letter for the column, A, B, C, D, E, or F. Since it doesn't make sense for a seat to exist independently from the flight it belongs to, we say it is a sub-entity and represent it with the second level of the flight transaction. Note that these two attributes together will serve as the identifiers of the second level. We already had the flight table corresponding to the first level. Now a second table will be added whose primary key will be composed of these three attributes, where in particular flight it on its own will also act as a foreign key to the flight table, that of the first level. This foreign key establishes the relationship between the two tables. Next, we'll add a secondary attribute to the seat, its location. That is, whether it's a window, middle, or aisle seat. This attribute will then be stored in the flight seat table. It's a good idea to define its data type as a domain, which we could name seat location. It will be of data type character of 1, for example, since it will store the letter W for window, M for middle, and A for aisle. Because it will only be able to take one of these three values and not any other. Then we will list the possible values and give them a name. So we don't need to remember the specific letter, which is arbitrary. It could take the values 1, 2, or 3 and it would be the same. What matters is that each value represents window, middle, or aisle. Later, to work with the values, we use the name of the value and not the stored value. For example, to assign a value by code to the flight seat location attribute. For example, using an assignment rule, we can do it like this, writing domain name dot value name. This will internally store the character W in the database attribute, the equivalent to writing the character directly. Similarly, it would also be convenient to define the seat char domain for the seat columns, because it will also correspond to an enumeration of 6 values, A, B, C, D, E, or F. To assign the flight seat char attribute to the F column, we use the domain name, dot, and the name of the value. This F here is the name of the value F. That is, it is equivalent to this assignment. In this case, it can be confused because they have the same name, but the value name is not the same as the value itself. Let's add all this in our KB. So we had the flight transaction, with a single level and the horizontal formula to calculate the price of the flight. We need to add the second level for the seats. We could ask the assistant to do it, but now that we are more experienced, let's try other options. For example, let's go to the source and add the second level just as quickly. Seat. Level name. Keys. Flight seated will be the seat row, followed by an asterisk to be the level identifier. Then flight seat char for the seat column, also followed by an asterisk because together with the row it will identify the seat on the flight. And finally, flight seat location, which will be a secondary attribute stored in the table. We still need to assign the data types. To flight seat char, we define the data type property as the seat char domain that we will already be creating in a single operation right here, setting it to character of 1. And for flight seat location, the same thing. Note how we see the second level in the structure. Let's save. Now, let's go to the Domains window so we can indicate that it will take exclusively enumerated values. If we edit the properties of the new seatchar domain of type character of 1, we see that under those of the type definition section, we have enum values. Clicking on the three dots opens the values editor so that we can add each of the enumerated values. So we will define the first one named A. The description can be the same A. And the value it will actually take within the data type will be the letter A. We press Enter and enter the next one, B, and so on until everything is entered. We press OK and see how all the values are specified in the property. Similarly, we define the enumerated values of the seat location domain. Now, if we go back to the transaction and edit the web layout, we see that it placed the expected grid so that the user can enter the seats. Additionally, because we defined the domains as enumerated values, it automatically chose to display each one using a combo box. For example, if we select the Flight Seat Location attribute control, in the Control Info group of its properties, we see that its control type is set to combo box, and its values taken from those of the domain. Let's execute. F5. The impact analysis report indicates that the flight seat table will be created with a primary key composed of these three attributes, as expected, and this one as secondary. We click on Reorganize and run Flight to enter seats. To Flight 1, we add a seat in row 1, column A, window. Then we add another seat in row 1. And we can see that since this field alone is not the level identifier, no error message is shown for repeating its value. But if we leave A for this field, an error will be triggered, because both attributes together form the level identifier, so they cannot be repeated. We see that the combo box displays all the descriptions of the enumerated values. We select B, and for the location, middle. Then we enter 1. C, aisle. D, aisle. E, middle. And press New Row to add the last seat of row 1. Seat F, which will correspond to the window. With this, row 1 of the flight is complete. We confirm. So far, Flight 1 has only 1, 2, 3, 4, 5, 6 seats entered. We may want this count to be calculated automatically, so we can immediately know how many seats a flight has. For this, we'll need an aggregate formula, the count formula, which we'll cover in the next video.